Okay, today's notes. Everything about today's notes covers two topics. We're going to look at fractions. Fractions or rational expressions, that's the official term. So we're going to simplify rational expressions and we're going to solve equations. We are also going to solve radical equations. The first half of the notes, pretty unrelated to the second half. So we'll take the first half, which has all the fractions, we'll take a break, and then we'll look at radicals. Okay. Quick review, if you can write this at the top, please. I just want to talk about how to do the 4 basic operations with fractions when we just have numbers. So if I have a fraction like 1/2 plus 1/4. Okay, in our 30 seconds, did we figure out how do we add fractions? What do we need? Common denominator. Okay. And then hopefully we remember if we're subtracting fractions, it's the same idea. If you're subtracting fractions, you need a common denominator also. Okay, so then the next question. If I have those same 2 fractions, but this time I'm multiplying them. Anybody remember how to multiply fractions? Charlotte?
Well, you can first, simplify.
Right, if I can.
Yeah.
Then what?
And then you multiply the top and then the bottom.
Okay, that's really important. You multiply the numerators and you multiply the denominators. You do not cross multiply. When do you cross multiply? What? Not quite.
If it's added,
Not quite. We don't remember when we cross multiply?
they're equal to each other.
They're equal to each other. So let's say you have something like this. X over 2 equals 1/4. So we have an equal sign now. Not multiplying, equal. That's when you cross multiply. And then last one that we need to talk about is what happens if you are taking 2 fractions and you are dividing them. Dividing by a fraction is the same thing as doing what?
Multiplying by the reciprocal.
Multiplying by the reciprocal. So division will change to multiplication, and it's the reciprocal of the second fraction. And then you just multiply like normal. We need to know these basic ideas before we throw some variables in. So every problem that we're going to do in example 1 is going to go back to one of those 4 ideas. Okay. If we go to example 1a, it says simplify completely. We're going to notice that we're multiplying. What I'm going to choose to do is start by multiplying. So we multiply across numerators, denominators. In the numerator, 3 times 6 is going to give us 18 t cubed rx. In the denominator, 4 times 5 is going to give us 20 r squared t squared. The order that you put the variables doesn't matter. At this point, we need to simplify everything. We're going to simplify the 18 and 20, the r's, the t's. If I start with 18 over 20, that's just a fraction that you're just going to simplify like a normal fraction. This is divisible by 2. This is divisible by 2. 18 divided by 2 would give us 9, and 20 divided by 2 would give us 10. So I've handled those. The other thing I noticed right off the bat, there's an x in the numerator, but nothing in the denominator for x. So that x stays. Okay, so I would like to address the r and the t. If we start with the t, we have t cubed over t squared. What that tells us is that we have 3 t's in the numerator and 2 t's in the denominator. So what that leaves us with is a t in the numerator. If you notice, what we did is we just subtracted the exponents. 3 minus 2 would give us t to the first. Okay, and so then if we look at our r, we have r and we have r squared. R squared means there's 2 r's. So we are left with 1r in the denominator. Again, we just subtracted. 2 minus 1 gives us 1 in the denominator. That can't be simplified anymore, so this is our full answer. Okay. Questions before we look at B? Okay. B, another multiplying problem. So we're going to multiply numerators, multiply denominators. Okay. Please don't do extra unnecessary work. Do you think I really want you to multiply those numerators? No, there's no way. There's no way I want you to multiply 4 and 3 terms and then 2 and 2. No. Instead, what we're going to do is we are going to start by factoring. So we're going to start by factoring, making things simpler instead of more complicated. So please rewrite all of the fraction bars. This 9 minus x squared is a difference of squares. So that'll be 3 minus x and 3 plus x. The 2x squared plus 5 doesn't factor. There's no GCF beyond 1, so that one is just going to stay the way that it is. When we do this x squared minus 2x minus 8, we're looking for two numbers that multiply to negative 8 and add to negative 2. So that would be negative 4 and positive 2. And I told you all when I saw you a few days ago that when there's 4 terms, that's normally the hardest for us to recognize. How do I approach factoring with 4 terms?
You split it up.
Yeah, you split it up. You put your line down the middle. I'm going to do that off to the side. So 2x cubed subtract 6x squared plus 5x minus 15. So GCF on the right side, I can take out a 2x squared, and I'm left with x minus 3. On the right side, I can take out a 5, and I'm left with x minus 3, which gives me 2x squared plus 5 and x minus 3. Okay, so we multiply across now. Don't actually multiply. Everything in the numerator will stay together. So we get 2x squared plus 5, x minus 3, x minus 4, and x plus 2. Denominator, we have 3 minus x, 3 add x, and 2x squared add 5. Okay, the idea with this is anything in both the numerator and denominator will cancel each other out. So the 2x squared plus 5s, those cancel. Okay, other than that, the only things that look similar are x minus 3 and 3 minus x. The question is, are those exactly the same? No. Here x is positive, here it's negative. Here 3 is negative, here 3 is positive. So what that happens when they are almost the same, but the signs are switched, is they do cancel, but they leave a negative 1. So our answer then becomes negative 1 times x minus 4, x plus 2, all over 3 plus x. That's how I want you to leave your answer. Do not multiply out the numerator. There's no reason to. That's just extra work for you.
Wait, why is that negative 1?
Because all of the signs are different. So we still have an x and a 3 here, 3 and an x, but the signs are opposite for every term. So instead of positive x, it's negative. Instead of negative 3, it's positive 3. That's why it leaves the negative. Okay, questions for me? Okay. So, last example before we go on to solving equations. Anytime that you have division, the very first thing you are going to do is change it to multiplying. Remember, when you are dividing, you're multiplying by the reciprocal of the second fraction. So the second fraction is going to flip. First fraction will stay the same. And now it is exactly like B. You're going to factor everything. All four of those factor. So what I want right now is I'm going to give you a break. Not give you a break. I'm going to have you do this example with your group. So we have to factor all four of these. Owen, how does y cubed minus 8 factor?
I got y minus 2, and then y squared plus 2y plus 4.
Beautiful. Thank you so much. This is one of the ones that the way I do it is y, 2, 2, 2. So then Owen brought down one of each, 1y, 1, 2, and then this is the pairs. So y and y gives you y squared, y and 2 gives you 2y, and you keep going. Okay, David, how does y squared add y minus 6 factor?
Y plus 3.
And how did you come up with those two numbers?
I don't remember what it's called.
Okay. Nick, can you help him out, please?
Because they multiplied it 6 and add to 1.
Yeah, multiply to negative 6 and add to 1. Okay. Benedict, how does y squared plus 3y factor? Yeah, good. We're just looking for a GCF. And last one, Diana, can you factor the last denominator, please?
Y and then y squared plus 2y plus 4.
Okay. Now, do we see that if we factor something wrong, we're definitely going to get the wrong answer? Right? So, our factoring skills have got to be pretty good. If we multiply across, anything that ends up in both the numerator and the denominator will divide out. So those divide out, those divide out, those divide out, those divide out. What's our final answer then? 1. 1. If everything in the numerator divides out, we're left with a 1 in the numerator. Everything in the denominator divides out, we're left with a 1. Hence how we get a final answer of 1. That is very unusual, just so you know. Questions before we do the last two examples before the break? Bless you.
Thank you.
Okay. So the question is, where is this leading us to? It is leading us to solving rational equations. You see the steps on the right. You're going to factor the denominators. You're going to determine the lowest common denominator. Clear out the denominator, solve, and check your solutions. I'm going to show you a little bit of a slightly different way to do this. This is how I approach the problem. Nobody likes fractions, so the first thing that we're going to do is we're going to get rid of fractions. Here's how we're going to do that. The first denominator, or the denominator in the first fraction, is an x minus 3. So to get rid of that, I'm going to need to multiply by x minus 3. So every fraction gets multiplied by x minus 3. I can do that because this is an equation. So because it's an equation, I can multiply every term by the same quantity. What that does is cancel out the first denominator and the last one. I'm still left with that x plus 4 then. To get rid of x plus 4 in that second denominator, I have to multiply every fraction by x plus 4, all of them. You are never allowed to just multiply one quantity by x plus 4. So what happens then is these x plus 4's cancel. So then we have to figure out what we're left with. In the first fraction, we have an x plus 4 and a 2x. Then we have an x minus 3 and an x plus 1. And then we have an x minus 1 and an x plus 4. So writing that out, that gives us 2x times x plus 4 plus x plus 1 times x minus 3. And then we have an x minus 1 and an x plus 4. I would love to tell you that there's like a nice, neat way that this works out and something that's going to make our lives easier. And unfortunately, that's not the case. To solve this equation, we're going to have to multiply everything out. So I'm going to distribute my 2x. and I get a 2x squared plus 8x. For the x plus 1 and x minus 3, you can FOIL, you can do the box, whatever is comfortable for you. So I get an x squared plus x minus 3x minus 3. And on the right side again, box, FOIL, draw the arcs, whatever you prefer. So we get x squared minus x plus 4x minus 4. Now we need to simplify. If I simplify everything on the left side, I get a 2x squared and an x squared is 3x squared. 8x, x, and negative 3x is 6x. And then we have the minus 3. Right side gives us x squared plus 3x minus 4. Okay, what do I do from here? Maria?
Make both sides 0.
Yeah, move everything to the same side. Okay, so we get a 2x squared, a positive 3x, and a positive 1 equals 0. That's what I need to solve. Brett, do you have any suggestions on solving that? If we try to factor, we're looking for two numbers that do what? Multiply to what?
Oh, sorry, I had a different way of factoring.
Ah, okay. Multiply to 2 and add to 3. Are there two such numbers?
Yeah.
Yes. So we're going to factor it. Thank you, Brett. So 2 and 1. So that 3x gets split into 2x and 1x. So if I factor out a 2x, I'm left with x plus 1. Factor out a 1, and I'm left with x plus 1. So this gives me 2x plus 1 and x plus 1. Whew, so our answers are negative 1/2 and negative 1. Okay, we're not finished yet. The step we've missed is checking solutions. When I say check solutions, what is normally meant by that? Plugging in your answer and making sure it works. You don't have to do that with a fraction. So write this down. With a fraction, all I want you to do is make sure that the denominator is not 0. That's all you have to do, and you can do it in your head. If you take negative 1/2 and you plug it into x minus 3, are you going to get 0? No. If you take negative 1/2 and you plug it into x plus 4, are you going to get 0? No. That answer works. Again, if you take negative 1 and you subtract 3, you don't get 0. If you take negative 1 and you add 4, you don't get 0. That tells us that both answers work. This is the only type of problem I will tell you that you can check your solution in your head. Every other type, when I tell you to check your solution, I want to see work. Questions before we do the last example before the break? I will tell you I'm going to start you off on B, but then you're going to finish B. So no questions? Okay. If you can factor a denominator, you need to. So in B, the only one that could possibly factor is x squared minus 4. Kira, does x squared minus 4 factor?
Yeah.
It does. What does it factor to?
X minus 2 and x plus 2.
X minus 2 and x plus 2. Alexia, if I want to get rid of the denominator on the first fraction, what am I going to have to multiply by? X minus 2. Okay, so first fraction, I'm going to multiply by x minus 2. But again, it has to be everything. And I can only do this because it's an equation. So when you have an equation, you can do everything. You can do the same thing to every term. So I did that, and these x minus 2's cancel, and these x minus 2's cancel. Elliot, what else will I have to multiply by to get rid of a fraction?
X plus 2.
X plus 2. And what do I need to multiply by x plus 2?
Everything.
Everything. So all three of the fractions. So these x plus 2's cancel and these x plus 2's cancel. So you are left with a 3 and an x plus 2, a 1 and an x minus 2, and a 12. At this point, you are going to finish this problem in your group. I'm going to tell you you need to be careful with this negative sign. That's where most people go wrong. So make sure you keep that negative sign. Ultimately, we should have gotten no solution. There are two things that students are most likely to mess up. The first one I told you is the negative. A lot of students don't distribute that negative. And then when I was walking around, the vast majority of you got 2, and you told me the answer is x equals 2. You have to remember, do a little mental check, denominator can't be 0. First denominator is 0, you're done, there's no solution to this equation. How do we feel about those type of questions? Or the rational equations? I will tell you that first one was a lot of work. Not every problem is going to be like that. More than likely they'll be like B, which go a little quicker. We are totally switching gears now. We're done with fractions. We're looking at radicals now. We have 4 problems. 2 of them involve simplifying. 2 involve solving equations. So let's just jump right in. Example 3, find the product and express in simplest form. You all have seen this before. It looks a little bit different because it has a fraction. It's just foiling or multiplying it out however you prefer. So that's what we're going to do. If you remember from before, numbers outside a square root can be simplified, and numbers underneath a square root can be simplified. So root 7 and root 5, both of them are roots. That becomes root 35. When I do root 7 and -1, -1 is outside the root, root 7 is inside the root, so that becomes -1 root 7. Similarly, 2 and root 5 becomes 2 root 5, and then 2 and -1 is -2. Question is, those first 3 roots, can I add them together? No. Not the same number underneath the root, so you're done. I don't care what order you put them in. Leaving it like that is fine. For the second term, just so you know, you don't need the 1. I put a 1 out in front, but you don't need the 1. B, am I allowed to distribute the squared? No. Thank you so much. Jamie, why not?
There's an addition sign.
Addition. If there's addition or subtraction, don't distribute the root. Instead, rewrite this. So this is root x plus 4 times root x plus 4. So again, at this point, FOIL, draw the box, draw the arcs, however you would like to do it. So let's see how we do. Liam, what is root x times root x?
It's x.
It is. It becomes the square root of x squared, bless you, because x and x is x squared, and then Liam already simplified it for us. The root and the square undo each other, and we just get an x. So then we have root x times 4. 4 is outside the root, x is underneath the root, so that becomes 4 root x. Likewise, we get another 4 root x, and then 4 and 4 will give us 16. Those middle terms we can add, so that becomes 8 root x, and then we have the 16. That's our final answer. That is simplest form, and that is standard form. We remember highest power on down to lowest. Questions on those before we move on to solving? Okay, last 2. Last type of equation we have to solve right now is a radical equation. You can see the steps out off to the right. Get the radical alone, square both sides, and then solve. I would like you to, again, circle that very last step, check solutions. This one you need to show work for. So, example A, we need to get the square root alone. I'm going to move 8 to the other side. That was step 1, get the square root alone. Then we want to get rid of the square root. The inverse of a square root is squaring something. On the left side, the square and the square root undo each other, and we're just left with x minus 2. And on the right side, 8 squared is 64. Moving the 2 over, we get x equals 66. You have to check your work. So I expect to see work for that. When I say check, what I mean is your answer has to go back into the very original equation. That's what we're going to do. So we get the square root of 66 minus 2 minus 8 equals 0. You cannot move anything from the left side of the equation to the right side. What's on the left side stays on the left side. What's on the right side stays on the right side. So this is always going to be equal 0. And what we need to see is, does the left side equal 0? Well, 66 minus 2 will give us the square root of 64. So this will give us 8 minus 8, or 0 equals 0. So our answer does work out. I will tell you on the quiz, you are expected to show that work. You will lose a point for every single problem where you don't check your answer. For those of you who took math applications, you needed to check your answer on some of the questions on the final. And some of you lost 2-3 points because you didn't check your answers at all. So we need to remember that that's necessary. I have a quick note I want us to write down before we do part B. So if you could write this down. If you're plugging in, like we just did, and you get the square root of 64. What is the square root of 64? Is it positive 8, negative 8, or both? Okay, this is kind of confusing. If the square root is already there, your answer will be positive. Instead of that, if we were looking at something like x squared equals 64, where we put in a square root, that's when you get a plus or minus. If the square root's already there, it's only positive. But if we put the square root in, you get plus or minus. You want my honest answer? I would keep yourself a list. Like I would just keep a list somewhere on your iPad or on a Post-it note or something of all the types where you have to.
Okay.
There's not a ton, but right now, fraction equations you can check in your head. Radical ones you need to write out work for. But there's no like rule of thumb. It's just you have to memorize which ones. Okay, last example. Let's see if we can get this done in the next 5 minutes. Don't square both sides yet because we got to get the square root alone. So we're going to divide by 2. Which leaves us with the square root of x plus 5 equals. If we divide by 2, 4x divided by 2 is 2x. 6 divided by 2 is 3. Now the square root's alone. Now we can square both sides. On the left side, the square root and the square undo each other. And we're just left with x plus 5. Okay, if we're going to make a mistake, this is where we're most likely to. How do we handle that right side? Yeah. Audrey, is that what you were going to say? Okay, so we have 2x minus 3 squared. That's 2x minus 3 times 2x minus 3. Are you okay if I just tell you what it ends up being? Without showing work? It ends up being 4x squared minus 12x plus 9. Okay, so moving everything over, that gives us 4x squared minus 13x plus 4. Okay, so we're going to look to factor this. Carly, if I was going to factor, I'd be looking for two numbers that do what?
Multiply 16 and add 2.
Are there two such numbers? Okay, I do want you to write this down. We would do quadratic formula. We're not actually going to do it. I'm just going to tell you what the answers end up being. Okay, so we end up with 13 plus or minus root 105 over 8. How many answers is that? 2. Why is this a mean problem besides the fact that you had to do quadratic formula? we have to check. So we would have to check x equals 13 plus root 105 over 8, and x equals 13 minus root 105 over 8. I'm not going to make you do that because that's just so incredibly rude. I will tell you the second one doesn't work. The addition is the only one that works.
Would there be a problem like this on the quiz?
No. No, there will not be a problem like this on the quiz, and if there is, I won't expect you to check. And I'll just tell you that. They should end up either being nicer whole numbers, or they should end up being like A, where they're easier to check.